Hello, my name is Garrett, and I am a math tutor at the DLASC. And today I want to go over how to solve separable differential equations. So there's not a lot of prereqs for this. The only prereq that we have here is that you have to know how to integrate, right? Because part of our prereqs is you have to know how to integrate. So great. And the reason why is because part of when you're solving a differential equation, the last step of what you're going to do is to do integration. You're gonna solve and do your front end work, and at the last step, you integrate it and you solve, and that is how you figure out your solution, your general solution to your differential equation. So the idea, basically, um, to solve a differential equation is you want to algebraically group or a separable differential equation, you want to algebraically group all your x's to one side and all your y's to the other. So, you know, and then at that step, you integrate both sides. So if you have like a dy over dx, um, let's say plus 2xy equals 0. Like step one is you want to be able to put all your x's on one side and all your y's on the other side and get in that form. So like in this case, what we'll do is we will say dy of dx, and we'll subtract 2xy from both sides to make it minus 2xy. And then, so we still have an x and a y on this right-hand side. So we want to be able to separate those. So in this case, what we'll do is I will divide y by both sides. So 1 over y dy dx equals negative 2x. And so the only thing is now is we want to isolate the dy dx. And this is kind of shorthand integration wise. But what we're going to do is we're going to divide dx or multiply dx by both sides. So then what we're left with is 1 over y. Hold up. We're left with 1 over y dy equals negative 2x dx. And from here, we have all our x's and all our y's on the same side. And that is the actual format that we need it to be in. And so from here, we can go ahead and integrate both sides. So we'll do that. We're going to integrate 1 over y dy with respect to y and negative 2x with respect to x. And see how that perfectly, that's the reason why separable differential equations work, is that way is because when you isolate the dy and the dx, now there's no other variables. And so you can just integrate them freely and it'll be completely legal. So we're going to go ahead and do that. So the integral of 1 over y is ln absolute value of y. And the integral of negative 2x is just negative x squared plus a c, obviously. Now, theoretically, we were supposed to have a plus a c on the y side also, but you can go ahead and shorthand that and just put it on the x side, because that constant that's on the y side can be added to the constant on the x side to make a new constant, so you don't have to worry about that. But we're still going to have to algebraically manipulate this for y. We want to try to isolate y. And so from here, what we're going to do is we're going to call this C1. And the reason why is because we're going to do some algebraic stuff and then we're going to make a new C. And so we'll call this C1. So right here, what we can do is we can take the inverse of our ln function with a base e. And so we can call this ln y. And what we do to one side, we do to the other. So we can call negative x plus C1. Now, here, what we can do, these will cancel out, and so you're left with just the absolute value of y. And here we can we can separate this and simplify it further by calling this e to the c1 times, because the bases, when you add bases, is the same thing as multiplying them, or add exponents is the same thing as multiplying the same exponent. So e to the negative x, squared here, squared there. So now that we have separated these, we can get the absolute value sign away by plus minusing e to the c1. And now we're almost done. Now we just have to clean this right side up. So you see here, now we call this C1. Here we can let our new C, our capital C, equal plus or minus e to the c1. And the reason we can do this is because this has become a new constant, right? The plus or minus e to the c1, right? If c is just a number, e is just 2.7. That's the numerical value. That's just a number. And so now we can let our new constant just be plus or minus e to the negative 1. And so when we substitute that in, we get y equals c to the e negative x squared. And this is the general solution to our differential equation that we started with, dy over dx plus 2xy. But the idea in its completion is you want to separate your y's and your x's. And then once those are completely separated, you want to integrate them, as we did here. And then all we do here is once these are integrated, that's a complete answer. Now all we have to do is just clean it up and solve for y and isolate y. And then that's what we can get a clean, beautiful general solution here at the bottom. And this is how you approach every separable differential equation problem, is to group the y's on one side, group the x's on the other, integrate both sides, and then isolate y. So that is how you integrate using separable differential equations method. And this is Garett with the DLASC. Happy studying, y'all.